Now we need to divide using short division. So first we have 5,862 divided by 3. So we can set the question out like this, with the divisor, the number that we're dividing by, on the left. Now we start by dividing the larger place values. So first we have 5 divided by 3. So we need to think of a number in the 3 times table that's as close to 5 as possible, but not more than 5. So 6 is in the 3 times table, but 6 is too many. We need to think of a number less than 5. So that's 3. And because 1 times 3 is 3, we write 1 above the digit in our answer line. But 1 times 3 is 3, and we need 2 more to get to 5. So 2 is our remainder, and we write that in front of the next digit. So now, rather than 8 divided by 3, because we wrote our remainder in front of the digit, we need to divide 28 by 3. So the closest number in the 3 times table to 28, which is still not more than 28, is 27. And because 9 times 3 is 27, we write 9 in our answer line. But that's only 27, and we were dividing 28. From 27, we need 1 more to get to 28, so we have a remainder of 1. 9 times 3 is 27, but we need 1 more to get to 28, so 1 is our remainder, and we write that in front of the next digit. So now we need to divide 16 by 3. The closest number to 16 in the 3 times table, which is still less than 16, is 15. And 5 times 3 is 15. But then from 15, we need 1 more to get to 16, so we have a remainder of 1. And we write that in front of the next digit. So now we have 12 divided by 3. That's exactly 4, because 4 times 3 is 12. So our answer is 1,954. The one thing to remember when we're dividing using short division is that the remainder will always be less than the divisor. So because we're dividing by 3, if we get a remainder, the remainder can only be 1 or 2. It can't be 3 or more. So now let's try 5,184 divided by 6. We can set the question out in the same way, but now if we look at our first digit, we have 5 divided by 6. But 5 is less than 6. So what we can do here is either write 0 up here and then write a remainder of 5 in front of the next digit, or what I like to do when we have the first digit being less than the divisor is to take the first 2 digits together and divide 51 by 6. So to divide 51 by 6, we need a number in the 6 times table which is as close to 51 as possible, but not more than 51. The closest number in the 6 times table is 48, and because 48 is 8 times 6, we can write 8, so the number we need to times by, in our answer line. But 8 times 6 is 48, and we have 51. From 48, we need to count on 3 more, or we need to add 3 to get to 51. So we have 8 remainder 3, and we write the remainder in front of the next digit. So we can check that that makes sense, because 8 times 6 is 48, plus 3 is 51. So now, rather than dividing 8 by 6, because we have our remainder 3 in front of it, we need to divide 38 by 6. Now the closest number to 38 in the 6 times table, which is still less than 38, is 36. And because that's 6 times 6, 6 times 6 is 36, so we write 6 in our answer line, but from 36, we need 2 more to get to 38, so we write our remainder 2 in front of the next digit. So now we have 24 divided by 6. That's exactly 4. So our answer is 864. Finally, we have 9,863 divided by 7. If we look at the first digit first, we have 9 divided by 7. That's 1 remainder 2, because 1 times 7 is 7, but then we need 2 more to get to 9. Now we have 28 divided by 7. Well, 28 is in the 7 times table. That's exactly 4 times 7, so we write 4 in our answer line, but because 4 times 7 is exactly 28, we don't have a remainder. So we can just move on to the next digit. We have 6 divided by 7, but 6 is less than 7, so we have 0 remainder 6. 0 times 7 is 0, and then we need 6 more to get to 6. So finally, we have 63 divided by 7. That's 9, because 9 times 7 is exactly 63. So our answer is 1,409. So let's have a look at this first question again, and let's think about why we write the remainder in front of the next digit. So for this question, we were dividing 5,862, so that's 5 thousands, 8 hundreds, 6 tens, and 2 ones, and we were dividing by 3, so we can share these place value counters into 3 groups. Remember, we start by dividing the larger digits, so we had 5 thousands divided by 3. We can share out 3 of these thousands, but then we get a remainder of 2. And the reason why we write our remainder in front of the next digit is that we can exchange 1,000 place value counter for 10 hundreds. And when we do this, you can see that we have 2,800 place value counters altogether. So we're dividing our 28 hundreds by 3. We can share out 27 of those hundreds because 9 times 3 is 27, so we have 900 place value counters in each of our groups. But there's one 100 place value counter that we can't share out. So that's our remainder, and remember, we write the remainder in front of the next digit, so in front of our 6 tens. And we can do that because we can exchange 100 place value counter for 10 place value counters. So now we have 16 tens altogether. We can share out 15 of those tens because 5 times 3 is 15, but then we have 1 remaining 10. We write the remainder 1 in front of the next digit because we can exchange this 10 for 10 ones. So now we have 12 ones, and we can share out all of those ones to get 4 ones in each group. So that's why our answer is 1,954. Then we had 5,184, so there's 5 thousands, 100, 8 tens, and 4 ones. We're dividing by 6, so we need to share these place value counters out between our 6 groups. We can't share out our 1,000 place value counters because we only have 5 of them, but we have 6 groups, and with division we need to make groups of the same size. But we can exchange each of our 1,000 place value counters for 10 hundred place value counters, and that gives us 5,100 place value counters altogether. We can share out 48 of those because 8 times 6 is 48, so we get 800 counters in each of our groups. But we have 300 counters that we can't share out, so we write the remainder 3 in front of the next digit, so in front of our tens digit, and that's because we can exchange each of our 100 counters for 10 counters. That gives us 38 10 counters. We can share out 36 of those with 6 in each of our groups. We write the remainder in front of the next digit because we can exchange these 10s for 10 ones. So now we have 24 ones which we can share out with 4 ones in each group. So that's why our answer is 864. For our last question, we had 9,863 divided by 7. So that's 9 thousands, 8 hundreds, 6 tens and 3 ones, and we're sharing these counters into 7 groups. We can share out 7 of our thousands to get 1,000 counter in each of our groups. We have a remainder of 2 thousands which we can't share out, but we can exchange these for 10 hundreds. So that gives us 28 hundreds altogether. We can share out all 28 of these hundreds because 4 times 7 is 28, so that's why we wrote 4 as the hundreds digit of our answer. But now we have 6 tens. We can't share out 6 tens because we have 7 groups. So we have 0 tens in our answer, but we can exchange these 6 tens for 60 more ones. That gives us 63 ones altogether, and we can share out all of these to get 9 ones in each group. So that's why our answer is 1,409, because in each of our groups we have 1,000 counter, 400 counters, no 10 counters, and 9 1 counters.